What is up, you hooligans? We are doing another FRQ review. This time it is the 2021 exam, question number 6. So we're going to be looking through this question together. It should be interesting. We got a slope field question, a differential, almost looks like a related rates question at the end. I don't think it is, but part C is a separation of variables question, which I think is really tough. So this should be a really worthwhile FRQ. I'm excited about it, but let's get to reading. It says a medication is administered to a patient. The amount in milligrams of the medication in the patient at time t is modeled by the function y equals a of t that satisfies the differential equation dy dt equals 12 minus y divided by 3. At time t equals 0, there is 0 milligrams of the medication in the patient. Okay, so part A says a portion of the slope field for the differential equation dy dt is equal to 12 minus y divided by 3 is given below. Sketch the solution curve through the point 0, 0. Now, we've talked about solution curves before in some of these videos, and basically, whenever they give you a solution curve, what we need to understand is that the little dashes represent the derivative at that point. So if I were to plug in, 2 comma 3, right? Well, that would be plugging into my differential, which is dy dt equals 12 minus y over 3. I would plug in that point into the differential, and I would get the slope at that specific point. And that slope is represented by the slope of that little dash, right? So looking at it, it looks like at x equal or some value, right? We don't know exactly what it is yet, but our derivative is just 0 because the slope is horizontal. It's just 0. So that might come up later. But if we were to sketch this, obviously I don't have it right in front of me. You could print it out and work on it. But our initial condition that we know is we start at 0, 0, right? There's 0 milligrams at t equals 0 hours. And what I'm going to do for a slope field is I'm basically just going to follow the dashed lines, right? So initially at, y equals 0, my slope will look something like this. And it will slowly flatten out as I approach kind of that line where there are those horizontal dashes. Because when there are horizontal dashes in a slope field, that represents an asymptote, right? So at y equals whatever, there's an asymptote. So we're going to approach it, but never quite reach it, just by following those little dashes in our slope field. So that's part B. All we gotta do, follow the dashes, make sure you got the right starting point, don't cross the asymptote. So that's part A. Not too tricky. Moving on to part B. Part B says using correct units, interpret the statement, the limit as t approaches infinity of a of t is equal to 12 in the context of this problem. Okay, well, let's think about it, right? In the context of the problem, we know that a of t represents the amount of medication that is in the patient, right? And it seems like as t approaches infinity, so as time goes on, the amount in milligrams of this medication will be 12. So I would say maybe as time goes on, the amount of medication in the patient will approach 12 milligrams. And that would be my answer to part B, right? Because it's as t goes to infinity, so we're going after infinite hours, like just the person's lifespan. Eventually, the amount of medication is just going to get really, really close to 12. It's going to approach it. It asked in the context, so I would put 12 milligrams, say medication, patient, try to include all those buzzwords that they give us in the question in order to get all the points for part B. But once again, not too difficult. Part A and Part B are both only worth 1 point, which is crazy because it means that C and D are probably going to be pretty awful, right? They're going to be tough. Let's check it out. Part C. It says use separation of variables to find y equals a of t, the particular solution to the differential equation. dy dt equals 12 minus y over 3. With initial condition, a of 0 equals 0. Now, separation of variables. We actually did this in the previous year's question. I think it was question number 6 from 2022, number 6. And it was very similar to this, right? But our first step is to get the right variables on the same side. So I'll multiply by dt, divide by 12 minus y. So I get 1 over 12 minus y dy is equal to 1/3 dt. And now I'm going to integrate both sides. Now, integrating this left side, I like integrating 1 over y minus 12 because I know that's just the ln of y minus 12. So I might actually negate both sides. So I'll get negative 1/3. Over here, I'll get y minus 12. So just negating both sides. But my next step is to integrate on both sides. So the integral of this left side of the equation for me, like I was saying before, gives me the ln of y minus 12, right? And on the right side, I get the integral of negative 1/3, which is just negative t over 3. And I will include this constant plus c. I explained this really in detail in the previous year if you want to check back. But both of these integrals will have a constant of integration, right? This plus c. But they're just generic. It's not like an actual value c. It's just saying, hey, there's a constant. So I'm just going to pull them all over to one side and say, hey, those two constants combined give us a constant, that plus c, right? So now what I want to do is solve for my plus c, right? So I will plug in my initial conditions. So on this left side, get the ln of 0 minus 12, which is negative 12, equals negative 0 over 3 plus c. So c is equal to the ln of positive 12. So now rewriting all of this, get the ln, the absolute value of y minus 12, equals negative t over 3 plus c. Now, we run into a slightly tricky thing about this question, and it kind of came up because I decided to negate both sides, get my ln looking all nice, right? But this y minus 12, right? Oh, shoot, I should have put ln of 12. But this y minus 12, it will always be negative across this entire interval because my y value is going to start at 0, right? And then it's going to go up. But as we saw in part A, it kind of has this horizontal asymptote at y equals 12. It can't equal 12 or be greater than that. So y minus 12 is negative. So the ln, or the absolute value of y minus 12, will actually equal 12 minus y, because the absolute value of a negative number is just the negation of it. 12 minus y. That will equal negative t over 3 plus the ln of 12. Now we're trying to solve for y equals a of t, so I need to isolate y. So I'm going to use my trick of doing e to the power of both sides. So on this left side, the e and the ln will cancel out. I'll get 12 minus y. And on the right side, I get e to the negative t over 3 plus the ln of 12, which I could also, factor this. Say this is e to the ln of 12 times e to the negative t over 3. So we could also write this 12 minus y equals 12 times e to the negative t over 3. If I split this up, because e to the ln of 12, that e and the ln will cancel out. So now to solve for y, I just add y over, subtract this, and I get y equals 12 minus 12 e to the negative t over 3. And that is equal to a of t. And that will be our final answer to part C. So really the one step that I did that just overcomplicated the problem was negating both sides, right? It made it to where we had y minus 12, and I had to think about, oh, well, the absolute value is actually going to be the negation. If you started out with 12 minus y and just integrated both sides like normal, this question would be way easier for you. So my little step I thought was going to be helpful, taking the integral. Turned out this concept of going from the absolute value of y minus 12 to 12 minus y, kind of complicated. But the general steps of separation of variables is the same as always. I separate the variables, get it to the opposite sides, integrate, solve the integrals, and I solve for c by using my initial condition. Once I solve for c, I isolate my y value. And that's it. So that is the correct answer to C, which was a 4-point question. So that was a large chunk of question number 6. But now we move on. One of the first 2-page FRQs I've seen in a while. When I was looking at this the first time, I thought we were done after part C, which would have been great. But unfortunately, we have part D to do. So let's read it. It says a different procedure is used to administer the medication to a second patient. The amount in milligrams of the medication in the second patient time t is modeled by the function y equals b of t. So before it was y equals a of t, now it's y equals b of t. That satisfies the differential equation dy dt equals 3 minus y over t plus 2. And it says at time t equals 1, there are 2.8 milligrams of the medication in the second patient, which is basically just saying when time is equal to 1, our amount is 2.5. It's an initial condition, right? Is the rate of change of the amount of medication in the second patient increasing or decreasing? Time t equals 1. Okay, so let's think about what they're actually asking for here. It asks, is the rate of change of the amount of medication? Well, the rate of change of the amount of medication would be b prime of t, because b of t is the amount. The rate of change is the derivative, right? And it's asking, is this increasing or decreasing? For a function to be increasing, right, its derivative has to be positive. The derivative of b prime is b double prime of t. So b double prime of t would have to be greater than 0. For it to be decreasing, just the converse is true. B prime of t would have to be less than 0. So I need to find the second derivative of this function at the point. Now the great thing is I already have the first derivative. I could solve for it by plugging in my initial condition. But I don't want the first derivative. I want the second derivative. So how could I find it? Well, when I take the derivative of the first derivative, what do I get? Well, the second derivative, right? So I'll get my second derivative is equal to the derivative of 3, which is just 0, and then minus the derivative of this function. Now I have a function divided by a function, so I know I'm going to use quotient rule. So I get t plus 2 squared in the denominator. For quotient rule, it's the denominator squared, then the bottom times the derivative of the top. Well, the derivative of y is dy dt, right? Minus the top, which is just y, times the derivative of t plus 2, which is just 1. So simplifying this out, my second derivative is negative t plus 2 times, I'll write it as y prime, minus y divided by t plus 2 squared. And this is at t equals 1, y equals 2.5. So I can go ahead and plug in those points. I get negative 1 plus 2, 3 times y prime, minus 2.5 divided by t plus 2, which is 3 squared. So all I need now is y prime at the point. And to get that, I can plug in my initial condition into the differential. And that gives me dy dt at this point is equal to 3 minus 2.5 divided by 1 plus 2, which is 3. And this arithmetic is slightly frustrating and difficult, right? But it'll give us something that is like 9 minus 2.5. It's a little bit annoying. It'll be like 6.5 divided by 3. That's my derivative. So now, when I plug it in for y prime, well, 3 times 6.5 divided by 3 is just 6.5. So this will equal negative 6.5 minus 2.5 over 9, which equals negative 4 over 9. And that is my rate of change of my rate of change, right? That is my second derivative. And because my second derivative is less than 0, the rate of change of the amount of blood being pumped into the patient, or the amount of medication being pumped into the medication, the amount of medication being pumped into the patient is going to be decreasing because our second derivative is negative. It's less than 0. And that would be our final answer for part D. So a really challenging part, right? Doing this quotient rule, going back in, plugging it in to get the first derivative, plugging that back in, can really be a challenge, right? This process of taking the derivative of the derivative and then plugging back in, we've seen this before. It shows up relatively often. It's not super foreign, but some of this arithmetic is difficult. Understanding what we're actually looking for, that it's b double prime that's greater than 0, not just b prime is greater than 0. That's a challenge. So we got a lot of difficult parts. But yeah, this is question number 6. We are done. We are done with the 2021 exam. And yeah, feeling pretty good about this. I hope that this was helpful for you guys. I really want this to just be an encouragement in your journey of calculus and math in general, right? I really love this stuff, and I hope that you guys are learning to love it more and more too. But I hope you guys have a fantastic day, and I will see you again very soon in the next video.